Hey everyone, we're working on point slope form today of a line. A little bit different than slope intercept form, which we learned on Tuesday. That is the standard y equals mx plus b that everybody knows as a line. Point slope's a little different. A little more difficult to graph as well. So we're going to work with that today. Hopefully we can understand that. And then I'll show you ways to get from point slope form to all the other three forms of a line. So the forms of a line we know so far we've seen. We have standard form, which was ax plus by equals c. One thing I want to point out on this is we always want to have a positive coefficient with the x. So it's never going to be minus ax. It's always going to be positive. So it's always going to be some number in front of x that's a positive number. Then we have slope-intercept form, like we said on Tuesday. That is the standard the normal y equals mx plus b. This is what everybody knows. This is what everybody learns in math. It's what everybody remembers from high school. It's why people don't like math. Everybody remembers that. And then the last one is the new one. It's our point slope form. Again, it's a little trickier. This is stated as y minus y1, so some value of a point, equals m times, in parentheses, x minus x1. So the x1 and the y1, that's a coordinate point that we're going to have. We're either going to be given or we're going to be able to pull from a graph to be able to write the equations of lines in point slope form from a graph. We're going to have to pick a point and then use our slope. Or we're going to be given a point to write the equation. We're going to have to use that from there. So point slope form, we use it to write an equation of a line when we're given a slope and an ordered pair. It's very useful when y-intercept point is not identifiable. So we can't readily look at the line and say, oh, the y-intercept is 0, -1. If it's kind of going between 2 points, then we're going to try to find some other point to write our linear equation in point slope form. So then as well as we don't actually have to go back and kind of solve for the b. But we always have to pay attention to the signs of the x1, y1 coordinate. The point slope form uses the opposite value of the coordinate value. So if the coordinate value, the x, is negative, it's going into our point slope form equation as a positive number. It will be x plus x1 then. If the x coordinate is positive, it goes in as the negative. You'll see it kind of as we do these examples. And then the same thing with the y coordinate. If the y coordinate is negative, it goes into the equation as a positive. If the y coordinate is positive, it goes into the equation as a negative. So remember, our standard form is y minus y1 equals m times x minus x1. So if our x and y values are positive, we're taking the opposite of that. We're just plugging the positive number in for y1 and x1. Think of it, we're taking the opposite. If the x values and the y values are negative, then it's going to be minus negative x. So that's where it becomes the positive. All right, so 2 examples. Show you really quickly here. They want us to write the equation of a line that has a slope of 3/4 and passes through the point 6,5. So we know our equation should be in this form. Y minus y1 equals m times x minus x1. They tell me my slope. Slope is the m. They give me a point that it passes through. I look. This is x1. This is y1. My values are positive, so they're going to just go into the equation. The equation is going to have minus y1 minus x1. So my equation becomes y minus, my y1 value is 5, so y minus 5 equals my slope is 3/4 times, in parentheses, x minus 6, because my x value is positive. And that's it. That's the equation of a line in point slope form. It's as simple as that. Does that make sense? If we were asked to write that form of a line in slope-intercept form, then we have to do that extra work of solving for b, plugging the points in to get the solution and trying to figure that out that way. Does that make sense to everyone? And then we'd end up probably with some sort of fraction of the y-intercept. Okay, our second one, we have the same thing. My slope is 4. my x1 and y1s here are both negative. So now I have to worry about my signs. Again, it's y minus y1. So if you want to do it this way, minus my y1 values minus negative 4 equals my slope, which was 4, times x minus negative 3. My x1 value is negative 3. Does that make sense to everyone to kind of do it this way? Then we just go back in and remember minus the negative becomes positive, so it's y plus 4 equals 4 times x minus negative 3 becomes x plus 3. And you have your equation of a line. It's as simple as that. Just make sure you're paying attention to the signs of the x and y coordinates. Okay, here's 4 problems I want you to do. I want you to go through and try to write the equations of a line and point slope form. On the first 2, there's only one possible answer because you only have 1 point. On 3 through 6, you can have 2 possible answers. I just need 1. I will show you 2 answers on the next page with the answers after you've entered your answers in the Edpuzzle. Like always, come back and check and see how you did. Okay, so here we go. Again, I wrote the equation of a line at the top. y minus y1 equals m times x minus x1. The highlighted lines are the possible answers you could have had. First one was just straight up, values positive, just plug them in. Number 2, I had to have a minus negative 1 there. There should be an extra parentheses there. But it was x minus negative 1, so that's going to eventually become plus 1 in my final answer. 3 through 6, we actually had to figure out the slope first. They didn't give it to us, so we have to remember the slope formula. You're going to be having to do this on the test. I'm going to give you 2 points, find the slope, plug it into our equation to find the right answer. So you're going to have to remember the slope formula, how to use it. It's going to be on the test for you. It's also going to be in your notes that you're going to be able to bring in. So that we would have had 2 possible answers there. The slope was 3 over 4. Question 4 are 2 possible answers there. Again, remember, watch the signs. In all of these problems, there was a positive and a negative sign in some of the points. My suggestion is if you can pull a point that has 2 positive numbers, do that because the equation is always easiest to write that way. Any questions on these? Hopefully we all got those. We're going to be moving on. Okay. Graphing from point slope form. Here we don't have a y-intercept. We have to figure out what point we're going to graph. Again, we have to look. We're given a point. We know there's a point in the equation somewhere because we know the equation is y minus y1 equals m times x minus x1. I know the point is x1 comma y1 is our point that I need to graph. So we're just going to pull it out of the equation. And that's step 1. Step 1 to do this is to identify the point from the equation. So I'm looking for my point in our equation there. My x1, y1, I remember what my equation should be, so I can really rewrite this. What it's supposed to be is x minus negative 3, because it's supposed to be minus. So now I have my point. It's negative 3 is my x value, and then 5 is the y value. We've identified that point. Now we go plot it. So I go over to negative 3, I come up to 5. There's our first point. Make sense? Okay, now just like always, we're moving based on the slope from that plotted point. So it's not from an intercept, it's from that point. We're moving by the slope. My slope in this example is 4, so it's 4 over 1. So I go up 4 to the right 1. I'm going to have a second point, it looks like, at negative 2, 9, and we mark that point. So here's my second point for my equation to graph my line. This is making sense. Step 5, as always, is to just connect the points with a straight line. Again, we're going to try to do this. If we're doing them written on the test, we're going to have rulers. Me trying to do a freehand from the whiteboard up front of the class, that's not a bad straight line freehand. But that's all we're doing. Identify the point from the equation. It's the x1, y1. It's the numbers in the equation that aren't the slope. Remember the signs. Most common error is people just plug in 3, negative 5. So their equation would look completely different. No, their line would look completely different. Make sense? Okay. Problems for you to try. Again, it's hard for me to check your work because there's really no way you can enter in the Edpuzzle. So graph your graph. Next slide will show you what it looks like, how it should have been. And then actually what I'm going to do is I'm going to have you enter an Edpuzzle that you get them right or did you go wrong. Was it close enough that you considered it right? Okay? All right, so that's what they should have looked like. The point you should have graphed should have been -1, 4. For number 2, it should have been 3, 5. Hopefully everybody got those. Here's 2 more to try. Again, graph them and then come back and see how you did on the next slide. Again, here's the points. Our first point should have been -1, -6. The second one should have been -7, 10. And the last two, we have the points. Make sure you're identifying the right point, graph them out, and then come back and check. Again, here's what it should look like. We had -1 for our x, 12 for y, so it's -1, 12, -11, 12, sorry. And then 3, -9, that should be. So I totally did this one wrong. Let me do it in a different color now because I made a mistake on that one. My point should have been -3, -9, so it should have been down here. And then it's up 12 from there, so it should have gone here. So it's going to be the blue. It's pretty close the way it was. It's just I made a mistake. Sorry about that. All right, so I had said we're able to convert from point slope form to the other 3 forms of a line. Because we're basically starting. The point slope is kind of the basic line where it's the easiest one to show everything we need. So to move from point slope form to slope intercept form, all we do is we solve the point slope equation for y. We got some distribution we need to do. We got a number we got to move from the left to get y by itself, and then we're in the slope intercept form from there. Whoops, sorry. From slope intercept form then to get to standard form, all we're basically doing is just undoing the operations to get y by itself. So when you kind of look at it, slope is basically dividing the right side of the equation by whatever the coefficient was in front of y. So you just kind of multiply both sides by whatever the bottom number of your slope is. Then you move the x with the coefficient back to the left. Then we're going to have to convert it to make sure that our coefficient in front of the x value is positive. We need it to be positive in our equations. So we'll have this example. First, we got to find, we want to write the 3 forms of the equation that pass us through those 2 points in all 3 forms. So we start with point slope form. I got to find my slope. So m equals, I'm going to do 7 minus -2 for my numerator over -2 minus 6. Sorry, minus 4. My bad. Minus 4. Going to be minus 6. So that's going to equal 9 over -6, which I will simplify to -3 over 2. That's my slope. So now I just got to figure out a point that I kind of have that works with my y value, my point slope form. So y, I am going to pick the first one. So I have y minus 7 equals -3 over 2 times x minus 2, so plus 2, because it was minus the x value there, so it's minus -2, so that should be plus 2. So that is our point slope form. Does everybody see that? Everybody got that? You could have used the 0.4 -2. I went with this one, and you'll see why in a minute, why I picked that. All right, so slope intercept form, like I said, we start with our point slope form. So my point slope form is y minus 7 equals negative 3 over 2 times x plus 2. So my first step is I got to distribute. I got to distribute negative 3 over 2 to the parentheses. So when I do that, I end up with y minus 7 equals negative 3 over 2x, mx, we see that, and then negative 3 over 2 times 2, my 2's cancel, I'm left with minus 3. Does everybody see that? I will kind of do it up here, because what I'm doing is I'm doing negative 3 over 2 times the fraction 2 over 1. It becomes negative 6 over 2, which simplifies to negative 3. Or I could have cross-canceled the 2's. Make sense? Everybody see that? All right, my last step now to get y equals mx plus b, I need y by itself on the right, on the left. Is add 7 to both sides. I end up with y equals negative 3, over 2x plus 4. Everybody see what I did there? Everybody kind of understand how we get to that point? There will be one question on the test to do this, to do the whole conversion from point slope form to standard form. All right, so to get from standard form now, I can go from my slope intercept form to standard form. So I'm going to start with that. I'm going to start with y equals negative 3 over 2x plus 4. Okay? We fixed that 3 over 2. That looks kind of bad. So what I want to do is when I'm trying to solve and undo stuff like this, I want to get rid of the fraction. So really, to get rid of the fraction, what I'm going to do is I'm going to multiply everything by 2. Now it's going to get rid of my negative 3 halves. So if I multiply everything in this equation by 2, I end up with 2y. My negative 3 over 2 again times 2, I've already done that over there, distributed, becomes negative 3x. That makes sense to everyone? And then 4 times 2 is just 8. So I end up with 2y equals negative 3y plus 8. So if we think about where we are, we'd be trying to convert to y equals mx plus b form, slope-intercept form. To get y by itself, I need to divide by 2. It gets me back to that y, the slope-intercept form that we had in the previous thing. Standard form again, remember, ax plus by equals c. I have y by on one side. I got to get the x over there, so I'm adding 3x to both sides. I end up with 3x plus 2y equals 8, because 8 is all by itself now on that right-hand side. That makes sense to everyone? Everybody see that? Equals 8. As we're getting ready for the test, we'll do a couple more of these in the review packet and then in class so you can ask questions. So I did it. I have my 3 forms of the line that went through those 2 points. I have point slope form here, we have slope intercept form here, and then we have standard form there. All right, so one last thing for you to work on. I want you to do what I just did. Write the 3 forms of the line, point slope form, slope intercept form, and standard form that goes through the point 5, 9, and 1, negative 3. Should take you a few minutes. Plug all 3 answers in the Edpuzzle so I can see how you did, and then come back and check your work. All right, so here we are where we should have been. Your point slope form should be y minus 9 equals 3 times x minus 5. That would have been the point I picked because I had said earlier, if you can have 2 positive values in your coordinate, use that as the point because it's always easy to use those points for point slope form. To convert to slope intercept form then would have been y equals 3x minus 6. Distributed the 3 through, move the 9, get y by itself. That's what I'm left with. And then the last thing is I don't have a fraction in front of my coefficient. My slope's not a fraction, it's a whole number. So I'm just going to subtract 3x from both sides. Then I have to convert it. I have to multiply everything by -1 because I want positive 3 in front of the x. I don't want negative 3x. I want positive 3x because the x comes first in standard form. So those quirky little things about math, we want our variables in alphabetical order. Does that make sense to everyone? There's a homework out there, graphing and writing equations of lines in point-slope form. One of the things you're going to have to do on the homework is from a graph, write the equation of a line. We didn't go over it here, but it's just pretty similar to slope-intercept. You just need to find some point that crosses a coordinate grid and plug that into the point-slope form. I will talk to everyone on Friday.